Hello guys, welcome back, and in today's video we want to solve for the value of x, and our math problem today is 8 raised to power x plus 2 raised to power x is equal to 30. So what is the value of x? So the first thing, we write this. So we have 8 raised to power x plus 2 raised to power x is equal to 30. So we can rewrite 8 as 2 cubed multiplied by x plus 2 raised to power x is equal to 30. Now instead of that, 30 can also be written as 27 plus 3. You can write also that as 27 plus 3. So this is 2 cubed plus 2 raised to power x minus 27 minus 3. This is equal to 0. Okay. Now applying the identity, we have the identity that a raised to power n multiplied by m, this is the same as a m multiplied by n. So we apply this identity to 2 raised to power 3 multiplied by x. So we'll have 2 raised to power x multiplied by 3 plus 2 raised to power x minus 27 minus 3. Okay, so this is 2 raised to power x cubed plus 2 raised to power x. We can divide 27 as 3 cubed. Okay, if you say 3 cubed is 27 minus 3, this is equal to 0. Okay, and then from here we can write again 2 raised to power x cubed minus 3 cubed plus 2 raised to power x minus 3. This is equal to 0. Okay, and then we say write 2 raised to power x bk. That's 2 raised to power x bk. So we substitute where there is 2 raised to power x with k. We'll have k cubed minus 3 cubed plus k minus 3. This is equal to 0. Okay, k cubed minus 3 cubed plus k minus 3 is equal to 0. Alright, so this part is the difference of cubes. So we apply the difference of cube identity, which is a cubed minus b cubed. This is equal to a minus b, a squared plus ab plus b squared. So we apply this identity to solve this difference of cube. Okay, so this will give us k cubed minus 3 cubed. This is the same as k minus 3. Into the bracket we'll have k squared plus 3k plus 9. Okay, k minus 3, k squared plus 3k plus 9. So we plug in this k minus 3, k squared plus 3k plus 9 back to equation. So we'll have k minus 3, then k squared plus 3k plus 9, then plus k minus 3. This is equal to 0. Okay, so we'll proceed as follows. We'll have k minus 3. Into the bracket we have k squared plus 3k plus 9. Remember here we have plus k minus 3. This is equal to 0. Okay, so if you check here, k minus 3 is common and k minus 3 is common, so we just factor out k minus 3. This will be equal to k squared plus 3k plus 9 plus 1. This is equal to 0. Okay, so this is k minus 3 into bracket k squared plus 3k plus 10. This is equal to 0. The first value of k, we have first value of k, which is k minus 3, is equal to 0. So that means k is equal to 3. Okay, That means the first k is equal to 3. Now from our quadratic equation, this is k squared plus 3k plus 10 is equal to 0. This is a quadratic equation. This is a quadratic equation. This is a quadratic equation. And this quadratic equation has got what we call a discriminant. A discriminant that is less than 0. We have a discriminant that is less than 0. That is to mean d, which is the discriminant, is equal to b squared minus 4ac. This is less than 0. It's less than equal, to 0. So if we substitute our b squared from our quadratic equation, this is our a, this is our b, and this is our c. So that means a is equal to 1, b is equal to 3, c is equal to 10. So now we are saying that our discriminant is less than 0. So we just say b squared minus 4ac is less than 0. So b squared is 3 squared minus 4 times 1, which is our a, times c, which is 10. So this is 9 minus 40 is less than 0. So that means that we have minus 31 is less than 0. Okay, minus 31 is less than 0. So in that case, that means that we have two complex roots, or like we have two imaginary roots. And these two imaginary roots, they are expressed in form of alpha is equal to a plus ib and beta is equal to a minus ib. So these are two imaginary roots that we have. Okay, we have the real roots and we have the two imaginary. So for this complex root, which are in the form of alpha is equal to a plus ib and beta, which is equal to a minus ib, we solve this quadratic equation using the quadratic formula. That is k is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so k is equal to our b is equal to 3, so it will be minus 3 plus or minus b squared is 3 squared minus 4, okay, minus 4 times a, which is 1, times c, which is 10, okay, divide everything by 2 times 1. So this will give us minus 3 plus or minus the square root of 9 minus 40, okay, divided by 2. So this is equal to minus 3 plus or minus, no, this is 9 minus 40 is minus 31 divided by 2. So we have a minus, so we can rewrite this as minus 3 plus or minus. Now remember this is negative 31, so we have minus 1 multiplying by that 1, and according to the complex roots theorem, we have minus 1. This is the same as I. Minus 1 is equal to, you're saying that applying the complex identity, minus 1 is equal to I. Okay, this is all divided by 2. So we'll have minus 3 plus or minus the square root of 31 multiplying by I divided by 2. So the first alpha, that is the first complex root, is equal to minus 3 divided by this 2 plus the square root of 31i, also divided by 2, and beta is equal to minus 3 over 2 minus is the same as minus a half square root of 31i. So this is the first root, and this is the second root. These are the complex root. But recall that we are saying let 2 raised to power x bk. That's 2 raised to power x bk. And from our real roots, we are saying that k minus 3, which is k is equal to 3 in this case, k is equal to 3. So if you say 2 raised to power x, this is equal to k, which is equal to 3. So in this case, to solve for the value of x, recall that we said that 2 raised to power x bk, and one of our real roots, which was given as k minus 3 is equal to 0, which we identified as k is equal to 3. And remember, 2 raised to power x, this is equal to k, so that means 2 raised to power x is equal to 3. Okay, so the next phase is to calculate the value of x in 2 raised to power x is equal to 3. So what we do, we introduce logarithm identity. Therefore, we'll have log 2 raised to power x is equal to log 3. We introduce logarithm in both signs. So we'll have x log 2, this is equal to log 3. So we divide both signs by log 2, divide both signs by log 2. So if you simplify, you'll have x is equal to log 3 divided by log 2. If you divide that, x is equal to 1.58495. okay, and then from there we are going to check, we are going to do a check from our original question. Remember, our original question was 8 raised to power x plus 2 raised to power x, this is equal to 30. So we want to prove, in other words, we prove if this is true. So we are going to have 8 raised to power 1.58495 plus 2 raised to power 1.58495, and this is equal to 26.99 plus 2.999. This is approximately equal to 29.999. So if you round off this etc. is going to give us 30. So it's true that 8 raised to power x plus 2 raised to power x is equal to 30, given that x is equal to 1.58495, and this is our answer. Thank you for watching and kindly subscribe.